Georgian here, bringing you physics from afar. I have my answer, and I have an intuitive response to the answer as well. I think it's a dead end. Well, this is how much time I spent on this. You don't have 9 minutes per question. However, you kind of do. If I were taking the exam, this would have been the kind of question that I had to say, I'm going to skip this and go back to it, and I would have chosen my favorite answer, then just moved on, and gone back to it if time permitted. I believe you're taking a paper and pencil test this year. My intuition, I believe, was incorrect. My intuition being that the answer was going to be found in forces up equal forces down. What kept bothering me was I was like, yeah, but where you put these forces affects how this might have an up or a down force on it. So for each situation, I wrote and rewrote what I thought were, and by the way, I haven't checked my answer yet. I'm gonna have to wait till the end of the video to see what I think my answer is and whether or not the College Board agrees with me or whether or not I live up to the College Board. Okay, so I wrote down, I decided, okay, I gotta put the pivot at the center, because if I put the pivot here at the point of interest, I have no information about the force that I'm interested in. So if there's anything you're gonna get out of this, it's, all right, if you're interested in something and you're trying to find that, you can't put the pivot there. So I put the pivot at the center, and that would eliminate the variable of this central force, and something interesting also happens when you move to the center. So, all right, so I decided clockwise, counterclockwise, clockwise. You can see I changed that at the last second. So my counterclockwise torques, the only one, assuming that the wall exerts an upward force, the only counterclockwise torque is provided by this, which would be this component of the tension. So that's Ft times the sine of theta times L over 2. The L over 2s are going to end up canceling out everywhere, which is a nice fact, given that we chose the center as the pivot. Then you have mg times L over 2 as a clockwise torque that's exerted by this, and then you have the wall's vertical force weight y times L over 2. Okay, you could solve for that and you get some value for force weight y. Then we can see that mg, for part B, I forget the exact wording for part B, but I'm saying that, part B is you move the cable to there. So the Ft sine theta disappears, and you end up with mg times L over 2 has to be equal to this only other counter torque. So that must be actually going down. That's a case where if you eliminate this tension and you put it to the center and you have this torque, you must have another torque going in the other direction. So my intuition was correct there, that in certain situations it might be an up or a down force. So that's certainly not, that's at least something. And then here we have tension times sine of the angle. This, I believe, is, they say keep this cable there, but slide the weight to the middle. And then you have that ends up being countered by this upward force, which seems like it would be substantial. And then when you finally move everything to the center, you realize it's going to be balanced at the center, because there's no torques you can find anywhere, because there's no longer a clockwise torque here or a counterclockwise torque here, because you moved them to the center. And therefore, there can't be a clockwise or counterclockwise torque on the other side, so it's effectively 0. So I'm saying the answer is D. My goodness. I wonder if they explain that. I mean, I don't know. Is this even a victory? I mean, a lot of you just kind of reasoned, well, if it's, and as I was looking at this, what actually got me was I started thinking, as you move things toward that, that actually increases the force. Like we learned that if you have two cables, two things holding something up, right? So this end is being held up and this cable is holding. If we were to slide this weight along, that's actually going to increase the force the closer we get there. But that's if we don't mess with the cable. If we move the cable around, that's not going to be true anymore. It's only true like if you have two supports like this, then you move things between those two supports, then